Welcome to today's presentation, Migrating Legacy Windows Applications with Habitat, packaging 13-year-old technology and running it in modern compute environments. Let's go ahead and get started. Matt, why don't you kick us off by telling our audience what we'll be covering here today?
All right, well, thanks a lot, Jamie. Yeah, I'm really excited to be talking about this. You know, usually when we do talks about Habitat, certainly all the talks that I've done on Habitat, we talk about more modern scenarios, perhaps applications that you're managing that you actually are building in-house and have source code for. But we haven't really devoted a lot of bandwidth talking about, really what is an important and key scenario for Habitat, which is packaging up legacy and legacy COTS applications. So COTS being commercial off-the-shelf software. What does that look like in Habitat? How do I package that, and how do I let Habitat manage that environment, and why would I do that? So that's what we're going to be really focusing on today, and I'm happy to be sharing that with you. So just to go over our agenda here real quick. So first of all, we're going to talk about what is Habitat. So I'm going to assume there may be a lot of people in this audience that just don't even have kind of a base understanding of what Habitat is. We'll be talking about where it fits in your automation tooling, particularly where it sits in comparison to more traditional configuration management tools. We'll talk about all the moving parts of Habitat. So Habitat covers a pretty broad surface area. It has several distinct components, and so we'll be taking a brief look at each of those. Then we'll be pretty much jumping right into our demo, which I say demo, but it's really I'm going to walk you through actually packaging up two legacy COTS applications. So we're going to be looking at SQL Server 2005 and an old ASP.NET application that was last updated in 2007. So it's running against the old .NET 2.0 CLR. So it's truly legacy. So we'll be looking at those applications. We'll be packaging them. We're going to export them to a Docker image. We'll see how easy Habitat makes that for us. And then we're going to go ahead and run them out of those two Docker containers. So we'll have two Habitat supervisors running these old school applications, but in a very modern environment. And then, of course, we'll leave some time at the end for Q&A. So let's jump into what is Habitat. I personally think that the easiest way to start talking about what Habitat is to start with Chef, since I'm going to assume, I hope this is a correct assumption, that the majority of this audience knows what Chef is and has their mind wrapped around that mental model. If not, maybe you know what Puppet is, or what DSC or Ansible. There's a broad array of products out there in the configuration management space, and all of those products essentially are focused on how do I make a particular server look and act and have its configuration be this very specific way. But here's the kicker, and usually that is a means to an end. That the end being, in the end, I want this server to run my application or my set of applications. And so it just so happens that in order for that application to run, the server needs to look a certain way. But what we've been finding, as we've been in this space for quite some time, really it's all about the application. And wouldn't it be helpful, perhaps, if we could kind of refocus the center of automation to the application? Now, don't get me wrong. I don't at all mean to say that this is like some progression where, focusing on the server is being phased out and focusing on the application is being phased in. That's not at all the case. I think that, for as long as we have servers, we are going to want and need server-centered configuration management. And there's a lot of places for that, OS hardening, things that are, that have concerns that run across the operating system will always remain there. But we're always going to be in this world where we care about our applications. And the fact of the matter is our applications isn't just this individual binary or set of binaries that run this particular program. It's usually at least one or two, services that are running in concert with one another. So for example, today we're going to be looking at SQL Server 2005 in a web application. that web application is not going to do any good without SQL Server 2005. So we need to have an awareness in our workflow of not just an individual server, but how services on a server relate to other services on other servers. So we need to be multi-server aware, but not just those servers don't just live in isolation from one another. We need to understand how they relate to one another. They need to be able to discover one another and utilize the services in an automated way on each other's platform. And so that is what Habitat really brings to the table. It brings to the table a bunch of abstractions that are key to automating your application, from application configuration, from connecting to services running on other nodes and coordinating with those services, and updating my application. So that's a lot of words, and I'm going to give you, before we actually dive into it, but we will dive into it and it'll make it more clear. But let's say some more words first, because Habitat is, as I mentioned in the beginning, it does cover a broad service area. So the point of Habitat is to really manage your entire application lifecycle. So it's looking to all the way at the beginning, from possibly building your application source, though that's not really what we're going to be looking at today. We're going to be looking at taking an application that's already been built, but certainly starting at the packaging of that application. So the first thing the first key component here is the Habitat Studio. So the Habitat Studio is an interactive shell environment that has the Habitat build system, and it also has a running Habitat Supervisor in the background. We'll talk about the Supervisor in just a bit, but it's there so that I can not only build my packages, but I can test my packages in this environment. On many platforms, what's going to happen is that environment actually lives in a container, so it'll spawn a container. So it's a totally clean environment. You just have, the idea is you have minimal OS, you just have Habitat, and that way you don't have other software on the outside, potentially bleeding in to your build process that might burn you when you run into production. But that's the Habitat Studio, where you actually create the Habitat package. Your Habitat packages then need to live somewhere, so they live on the Habitat Builder service. The Habitat Builder service acts as a binary repository for these Habitat artifacts, these what we call heart files. And in the wild today, we really have two key incarnations of this Habitat Builder service. So we have our live Habitat Builder service, which, by the way, can actually do the building too. You can connect that to your GitHub repo that has your Habitat plan. And if you don't know what plan is, it's okay. We're going to be looking at them and explaining them in a bit. And then it can build them when it sees changes. Now, enterprises, and I'm thinking probably a lot of environments where we're going to be talking about, legacy COTS, those types of environments may very well be consuming our on-prem Habitat Builder solution, which actually doesn't do the building, but certainly acts as a place where you can store these repositories. And in the future, they will do building too. That is on our roadmap. So that's where so you build the package, you store the package, and then if you go to the far right of this graphic, you've got the Habitat Supervisor. So the Habitat Supervisor is the actual runtime component of Habitat that runs on your application server. It will launch your application, start up your application, manage the configuration of your application. It can, update your application, and it will consume the packages inside of the builder service. So when I tell my Habitat Supervisor, hey, I need you to load this particular package, it's going to go out to the builder service and say, hey, I don't have that package. If it doesn't, give me the latest package for that. And possibly what it will do afterwards, after it runs my application, is it will continue to pull that builder service, if I tell it to look for updates to my application. And when it sees them, it could potentially roll updates of my application across, roll those updates across my fleet of application servers. So that's those are the key components. Again, we're going to actually be looking and playing with these components in this talk. Before we actually dive off into the demo environment and start doing stuff, let's just touch on how do we traditionally do today legacy COTS migrations, and how does how does Habitat change that landscape? So traditionally, the key approaches that people use for migrating legacy applications typically follow two paths. They rewrite the application, so it's a full rewrite to take this old application, make it cloud native, basically, make it interact with these new cloud APIs that they'll find in a more modern environment, or a lift and shift. So you literally take maybe a backup or have some kind of a fingerprinting mechanism where you essentially freeze the state of the application that's already running on a server, and basically just shift that over to architecture in your more modern data center and run it out of there. You haven't really discovered anything new particularly about that application, but you're at least able to grab the bits and plop it in its new location. Now Habitat takes a slightly different approach. So with Habitat, there's several approaches that you could potentially take with Habitat. What we're going to be talking about today in the talk here is essentially repackaging your application. So we're going to create a Habitat package for your application, and then we will be able to use Habitat to automate the installation and configuration of that application. So, in the links in your resource list, I actually have a post that talks about how can you create a Habitat package for COTS applications. There's lots of ways to do it. There's two kind of key high-level ways. One is, and the kind of the ideal, what I call the purest path, is to be able to totally isolate this application. To suck all the binaries maybe out of the installer that was given to you by the third-party vendor, to have Habitat place those binaries, where they're intended to be on disk, but inside of the Habitat file system, have Habitat totally control calling the binary that runs your application, maybe set some configuration files, some environment variables, and everything kind of runs inside of that sphere of Habitat. And that's a great model that works particularly well in more modern applications that are just kind of wired to operate that way. Unfortunately, in the COTS world and in the Windows world, that can be more difficult because we have to deal with these machine scoped abstractions, like, for example, the Windows registry, the firewall. We have to reach outside of Habitat and affect these outside systems. Furthermore, it may be just overly burdensome to reverse engineer our installer to figure out everything that installer does. So what you can always do, and what we're going to demonstrate, and sometimes really it's the only feasible path, and I think SQL Server fits that bill, is basically to repackage that installer. So our actual Habitat plan isn't going to do a whole lot on our build server. And then at runtime, we'll feed it all the information it needs to do the install and do the configuration so that our application can run. So let's, without further ado, let's actually jump in and actually do this. So I'm going to share my screen. Oh, I actually have to hit the share button here. Okay, this can take a few seconds for it to actually render inside of inside of your app. So while it's doing, I'm just gonna jump into this, and eventually it should pop in. But what I'm looking at now is VS Code. I'm looking at a Habitat plan for SQL Server 2005. So this is what Habitat needs. So a Habitat plan is basically the basic building block of a Habitat package. So this is what tells Habitat how to package your application. So if you've seen other Habitat demos before, you've probably seen in this lower part a lot more lines of code, because you can also, you can conceivably build your application from source, so you can compile your source code and all that. But with COTS applications, we don't do that because we don't have the source code. And we'll get into the nitty gritty down below in just a bit. But basically, regardless of what style of Habitat plan you're looking at, you're always going to have two basic parts of your plan. You're going to have a top part that is defining metadata about your plan. So basically just some basic information that you would pretty much expect any packaging system to support. So what's my package name? What's my package version? What's my licensing? And then some other information that's going to be a key part in the packaging functionality. So things like our package source. So here we have the actual public download link of where to actually get, in this case, SQL Server Express. Now, before people panic and say, well, SQL Server Express, I don't care about SQL Server Express. I'm running production here. I can't run with that. So the README of this repo, and like Jamie said, so in your resource list, you're going to have links to everything that I'm showing you today. All the demos that we have, these links will have instructions on how to do this step by step. So you can do this yourself. You can look at everything in more detail. But this particular repository that we're looking at, where this plan comes from, is our Habitat Core Plans repository. So we have a bunch of plans in our Core Plans repository. And the idea is that all of these plans should be either open source or freely consumable to the public. Now, obviously, SQL Server is a paid-for product. If you're going to run SQL Server Standard or SQL Server Enterprise, you're going to pay for that. But SQL Server has a free SKU, SQL Server Express, that's pretty much functionally equivalent of SQL Server Standard, but it has some constraints that would preclude you from wanting to ever run it in a production environment. But it's going to do fine for the purposes of this talk. So real quick too, if you wanted to run this with your own enterprise or standard version of SQL Server, if you look at the README, it'll show you how you can do that. You can actually point it to your own SQL install, and it'll manage that. But at any rate, so this is where it's going to get the actual the payload for the application, the installer. So if I'll scroll to the end, we can see this is an exe file. If we were to actually invoke this on our local system, it would actually launch the SQL Server installer. We have an area where we can describe some dependencies. So here we're going to take a dependency on a package called DSC-core. So we're actually, this one and in our web application, we're going to utilize DSC. So that is Microsoft PowerShell desired state configuration. And that actually works very nicely with Habitat. Here, we're going to actually use it for setting some firewall rules and for pulling down the .NET 3.5 runtime for enabling that feature. We'll look more specifically at that in a bit. Here we're saying, so remember, Habitat is partly about services talking to one another. So that is done through what you can kind of think of as a contract. And you have two sides of that contract. You have a producer and a consumer side. And what this is the producer side. So I, as SQL Server, am saying that I will or can expose certain configuration about my environment to other applications running inside of the same Habitat Supervisor environment. So they can discover me. They can discover what port I'm running on. They can discover perhaps a password and username. That's just how I wrote this. You might just deal with AD service accounts, and that's fine too. You would author this differently in that case. They might need to know what named instance I'm running on. So these are I know that in order for me, my web application, in order to be able to write a successful connection string, I'm going to need all these bits of information. So SQL Server is going to say, okay, this is what I'm going to give to people. So then we get into the second main part of a Habitat down here in these functions. So these are the Habitat build callback functions. And so when the Habitat build runs to build a Habitat package, it can call out to any number of functions that you can implement. And depending on the complexity of your build, that will determine different functions that you might implement. This is pretty standard. All we need to do is just pull down that executable and yank out its content. So, and let me get into that real quick. So that SQL Server executable is actually, so that the contents of that executable isn't actually the SQL Server binaries. I mean, somewhere down deep inside, there are the SQL Server binaries. But the next level, like if I were to extract, which is what I'm going to do, the contents of that executable, I would get the SQL Server setup media, basically. So I would essentially get a mirror image of what I would expect to see if I downloaded like a SQL Server ISO file that had all of its setup media. So I would have like setup.exe, I would have a bunch of MSI files, all the binaries that the SQL Server installer needs to run. So what this package is going to do, what this plan is going to do, is it's going to download that, and in invoke and pack, it's basically going to call that file that I downloaded. So it's going to call that executable, but it doesn't want to actually install SQL Server. So we pass it this argument, this /x argument, and we tell it where to lay down where to place the contents of that executable. And by the way, you probably noticed this is all PowerShell. So all hooks, and I'll be talking about hooks in a bit, and the plans for Windows-based packages are 100% written in PowerShell. If this was targeting Linux, it would be Bash. So I've extracted that executable, and then in my invoke install, so invoke install basically tells Habitat, what am I going to include in my package? So I'm going to include everything that I extracted. So I'm going to copy everything that I extracted out of this installer. I'm going to copy it to this package_prefix directory. So this variable, along with a lot of these other variables that we've seen, I won't get into the nitty-gritty about. You can check out the documentation if you want to drill into that. But this particular, these are supplied by the build system. This particular one is essentially the Habitat package staging area. So whatever I copy into this particular directory is going to be included in my Habitat package. So in the end of this build, I should have a Habitat package that has all of the SQL Server setup media buried inside of it. So that's what I am packaging for. And in this case, it's going to be for the SQL Server Express SKU. So now that I have that setup media, that I've kind of gathered up into this package at build time, how do I make sure and how do I coordinate when the Habitat Supervisor starts up on the node, the application server, that SQL Server gets installed properly? So we do that with hooks. So everything in this hooks directory is an individual PowerShell script that the supervisor at runtime will invoke. So when the supervisor launches an application, there are certain checkpoints along that application's runtime where the supervisor will invoke these hooks, and all these hooks are optional. So if I want to like hook into one of those lifetime events, I'll write one of these scripts. So in my init hook, this is where the SQL Server, where the Habitat supervisor actually loads my application. My run hook is where Habitat actually runs the application. If I have special logic like I do that I want to run to configure SQL Server, but I know that SQL Server has to be in a running state, I would put that in my post-run hook. But they're all just PowerShell. Now, so this is my init hook. And as you'll notice, there's a lot going on here. If anybody here has installed SQL Server in an unattended fashion, you know that it's oftentimes more than a one-liner. I'm not going to go through this line by line. Again, you can revisit this on your own. But basically what I'm doing, there's a few things. So I have to make sure that the .NET 3.5 runtime is installed. The SQL Server 2005 installer can't run without that. So I utilize DSC to do that. Now, and real quick before I move on here, you may be wondering, well, what are these double braces? This does not look like any PowerShell that I've ever seen, because it's not. So all the files that are inside of this hooks directory and inside of this config directory, which we'll be looking at in a bit, they're also known as Habitat templates. So Habitat leverages the handlebars templating syntax that will allow us to have the supervisor basically inject data at runtime that we may not be aware of at build time. So, so at any rate, so I am going to have DSC apply this .NET to, there's a configuration in this file. So if I go here, I can see this is just if anybody is familiar with DSC, you'll know this is just a DSC configuration. This is going to enable the .NET 3.5 runtime. And here again, I've got these double curly braces. And basically what this tells the supervisor is if I've set this setting called netfx_source, if you have an awareness of that, then make sure you include this parameter in this DSC configuration that will point it to the source. So when DSC enables a Windows feature, you can, by default, if the bits for that feature aren't on disk, it will go out to the public Windows update servers to get it. But as an alternative, you can point it to your own source. If you have like a Windows operating system install disk available, you might want to point it to that. And it just so happens the .NET 3.5 runtime is probably maybe the only feature that if you don't enable it, not only is it not enabled in your operating system, the bits for it aren't even on disk. Because it's so old. Like we moved to the .NET 4 CLR in like 2009, at least, I think. And so they don't even bother putting this on disk anymore. But by default, if we don't have the source, it will go out to the Windows Update server. But as we'll see, we're going to actually need to give it a source. And we'll talk about why that is in a bit. So eventually we do some logic here to figure out, okay, what's our setup.exe program? So as I mentioned before, you could have this point to your own installation media. So there's a little logic like, well, am I going to do the SQL Server Express that I'm configured with, or am I being pointed to some alternate install media that might have the standard or enterprise version of SQL Server? So it figures that out, and basically it gets around here, here. And it invokes that setup.exe file, and it passes this settings argument and passes along with that a config.ini file. So for anybody that's ever done a SQL Server install, there's like a whole bunch of different parameters I could conceivably pass to the SQL Server installer. And I can make this particular call a lot cleaner. Instead of installer, I can instead just forward it this ini file. And so we have this ini file. It knows, so I'm using the double braces because I don't know at build time where this ini file is going to live. The supervisor will know when it unpacks the package. And so the supervisor will expand this right here to the absolute path where this lives. And so I keep it here. And again, this is also a template. So these values, this is the ini file that SQL Server expects to get. That's going to tell SQL Server, all the settings to set it with, things like the SA password, the service account, things like what features of SQL Server to install. So again, because this is a template, the supervisor will inject this at runtime. So I could have different environments, for example, that the supervisor's running on, and I might want the SA password to be like some vanilla password on my dev environment, or I might want it to be something much different on production. Now, we do have the ability to pass in basically safe defaults. So I might not necessarily want to have to pass in all of these configuration values every single time I load my application. So we do have available to us this default.toml. So unless I tell the supervisor otherwise, it's going to use these values. So these are basically like my safe default. So for example, the service account, I'm going to use the network service. That's a safe default to run the SQL Server service under network service. So this is essentially how this all gets tied together and installs SQL Server on the machine. The only other hook I think I'm going to talk about here is the run hook. So the run hook tells Habitat how to actually start your program, to start your application and to run it. Well, as people know, or anybody that's familiar with SQL Server and a lot of other Windows-based applications, is they may run like SQL Server does as a Windows service. So there's not an executable that I actually invoke directly. So basically, this run hook essentially becomes a wrapper around the Windows service. So I start that Windows service. I then basically just kind of spin for as long as I know that service is in a good, runnable state, as long as its status is running. And then if for whatever reason somebody were to yank the cord on that, were to actually stop that service, or if Habitat were to be told explicitly to unload or stop that service, I have this finally block where I can cleanly shut down that SQL Server Windows service. So that is my SQL Server plan. If you wanted to look at all the files involved here, again, you could do that at your leisure. But really the next step that we need to do, that we want to do, is we want to actually build this plan. So let's take a look at what that looks like. So I'm going to run this command. So I'm going to run hab package build. I'm going to give it the directory to where my SQL Server 2005 plan is, and I'm going to pass -w, which I'll talk about in just a little bit. So what is happening now is the Habitat build system is building my plan. Now, if anybody here has seen a Habitat demo before, this may be a little bit different from the way that you've seen plans built in the past. So often if I were in more of a development environment here, maybe this is my own application, I wanted to test how to build this, I would enter into what we call an interactive Habitat Studio. And so I would have typed hab studio enter, which would have taken me to this interactive PowerShell prompt, actually inside of a running container, so it's totally clean. And I could do things like I could run my package build, I could test it because there would be a Habitat supervisor running inside of that studio. Testing it would naturally install SQL Server. Because I'm inside of a container environment, that's cool because maybe I don't want SQL Server installed on my local machine, and I can exit out of that studio, and then the container goes away, and poof, all trace of SQL Server is gone. So it's a totally safe environment for me to test out my builds. However, in this case, first of all, I'm limited by time for this talk. And I've done, I've built this thing hundreds of times. I know it's going to build just fine. I don't need the overhead of a container, so I use that -w parameter, basically saying just do this, do this locally, because all I'm doing is I'm pulling down a file from the internet, I'm unpacking it and copying it into a package. So I'm not worried about the state of my machine being tarnished. It's faster to do it that way. So that hab package build, basically under the hood, it opens up a local studio, does the build, and comes out. And I also just think it's a good, I've always wanted to have a demo where I could demo that, because that's also a great thing to have in your in a CI environment. So in a CI environment, if I want to hook Habitat into my Jenkins workflow or my VSTS workflow, for example, I might have it do a hab package build, and then it's going to build my Habitat artifact for me. At any rate, we've done the build. The build is finished, and I now have this heart file that contains all that setup setup media for installing SQL Server. So while I don't necessarily want to test it in a studio environment in this demo, I do want to show everybody it running and validate that what Habitat does with that. So what I'm going to do, that the easiest way for me to do this is to launch it in a container. Now, you may not be running containers on your production fleet. That's fine. Habitat can run as a Windows service on any VM. But just here in this demo environment, and this is great, also just for testing purposes, to just spin up a container. Sometimes there can be an initial delay to get the first container pulled down, the first Windows container, because they can be kind of big. But once you have them, it goes much faster from there. But at any rate, the first thing to do is to actually export this package. I can do this to any Habitat package. I can export it to a Docker image. So I'm going to type hab package export Docker. So I want to export it into the Docker format. And then I'm going to give it the path. So we'll run that. So what's happening now? So that one command, basically what Habitat does is it's going to create an image that has everything that my application needs to run. So it's going to start off with a base image of Windows Server Core. So that's basically, you think of that as vanilla Windows 2016 Server Core operating system. On top of that, it's going to add basically what Habitat needs to be Habitat and to run Habitat packages, so that the Habitat supervisor and some dependent components of the supervisor. And then it's going to add my actual package, along with any dependent packages that my package has declared, along with any of their dependent packages. So basically the entire runtime dependency tree will get sucked into this image. So in the end, it's basically, under the hood, creating a Docker build file and creating a an actual a Docker image that I can later actually run and have it spawn a container, start up the Habitat Supervisor, and call into my application. So this takes a few minutes to finish up. It's probably got another minute to go. So I'm going to kind of let this run in the background. And in the meantime, we are going to go look at the other application that we want to package. This is our old school ASP.NET application. It's called SQL Web Admin. This is basically an application, a web-based SQL Server management console. And you could find this, like I found it, on the CodePlex archive. So for those who aren't familiar with CodePlex or never dealt with CodePlex, CodePlex used to be essentially an equivalent of GitHub. So it was a popular place for Microsoft-based open source projects. People would put their projects here, and just like GitHub, you could file issues against them. You could see the source code. You could, authors of these projects could upload their releases. Nowadays, everybody uses GitHub, but they have taken all the projects that were once on CodePlex and archived them that you can get in these little zip file, well, sometimes they're big zip files that have, inside of them, all the issues, all the releases that made up that particular project. So we are going to, so that's where we're actually going to download the code. So we're going to download the code from the CodePlex archive. A couple other things that are different. So this should look pretty familiar compared to our SQL Server package. One thing is we have an extra dependency over here. So we're also going to use DSC in this package, basically to do a lot of IIS configuration. Or not a lot of it, but enough IIS configuration. We also have a dependency on this other package. So we have a Habitat package for SQL-DMO. Those are the SQL distributed management objects. You probably don't see them much today. It's an old COM-based library for directly interacting with SQL Server objects. These days we use .NET. Back here we use COM. So again, this is a good example of something truly legacy. And in our init hook, we will actually do a red cert. Anybody that remembers COM, good old red server 32. That's where we'll register that component. But I'm not going to get into those nitty-gritties right now, but again, this is in your resource links. You can totally look at this. This is its own repo. You have a link to this in your resources. So here we've got, this is the other interesting thing here. This is the consumer side of that contract I was talking about earlier. So in our SQL Server plan, if you recall, we had this bit right here where it said this is what we're exposing to a potential consumer of our services. In this plan, we're saying, this is what I expect to be available to me. So on the left-hand side of this equal sign, we call this a binding alias. So I'm just creating this arbitrary string because I'm going to use this later, and we'll see how that gets wired up. But I expect this thing to be called, that we'll call it database, and it needs to expose to me these four properties: instance, username, password, and port. I need those in order to create a connection string to be able to connect to SQL Server on that. So then inside of the actual callback functions here, this is a little bit different. So in my invoke unpack, here I'm calling into this Habitat provided function called invoke-default unpack. So that's the default behavior of unpack. If I were to provide no implementation of invoke unpack, that's what would get called, and that's what would basically just simply unzip this CodePlex archive zip file. But there's some additional stuff I need to truly do the unpack, because inside that zip file really are a whole bunch of other zip files. So as I mentioned, these CodePlex archives contain all the releases of that project. So I need to do a little bit of PowerShell here to find what was the last project. So after that's been extracted, I find the very last release inside of that archive, which will itself be a zip file, and then I will unzip that file, and that's going to have all of the the ASP.NET files and binaries. So my DLL, my ASPX files, my CSS files, all those files that make up this website. And then I'm going to do basically the same thing that I did in SQL Server. I'm going to copy all of that stuff into this package prefix directory, because all of that that's what I need to package in this case. I need to package all of those bits. and then at the very end, I tell it, but don't include, delete from that staging area, delete the web config and delete these two files. So I don't want to drill too much into the weeds here, but basically I made my own copies of these two files. I made some small tweaks to them. And let's look at one, because this is pretty material to what we're doing here. So global.asax.cs, I made a copy of that and put it in my own config directory. So this is now a Habitat template. And I really want to zero in on this. So basically, this is code. And if you're not familiar with C# code, that's totally cool. What's important here is to know that I've got these double braces, and these are the parameters that I need to instantiate this C# admin user object, because that's what it's going to use to actually create a connection to the database. And because I'm using these double braces, the supervisor is going to be able to inject the information that it knows about the running SQL Server service here, so that at runtime, my application that the supervisor is running will be able to successfully make that connection. The other thing I'm just going to point out here is we do have another DSC configuration. So as you know, although I've packaged all of the binaries and files that are included in my website, that's not going to do me any good unless IIS knows what to do with it. So first, so this is everything that we need DSC to do. So we do, just like in SQL Server 2005, because this is an old school website, I do need the .NET 3.5 runtime. I need ASP.NET enabled. I need static web content enabled, so I can render things like CSS files and graphics images. I need to configure my IIS application pool. If you're not familiar with IIS configuration, that's totally cool. But if you are, you'll know by looking at this, this is clearly a legacy website. We're running in 32-bit mode. We're using the classic pipeline. We're using the old 2.0 runtime. And the beauty of this is like when you get this code from the Codeplex archive, or get code from wherever it is that you're getting code, sometimes it's not easy to figure out how to actually make it successfully run in IIS or in whatever context that it is you're running in. And so because I know some things about IIS and ASP.NET applications, I'm able to look at those error messages and figure out, okay, these are the settings I need. But it takes a little bit of troubleshooting. But the great thing that I like about this is that once that troubleshooting is done, I now basically have executable documentation that I can take this and plop it anywhere, and it should run inside of any Habitat supervisor. And then so I'm also configuring my IIS website. Here I'm telling it, this is the supervisor will know where the actual files are that I've packaged. It also knows what port to listen on based on whatever I've configured. By default, we'll be running on port 8099. So that is our ASP.NET package. So let's go back now to this image that we were building. Okay, cool. So that's done. So now what I'm going to do is I am going to we have an image for SQL Server 2005. So I do want to run this and just have us all see that it's truly, this is a good image that can really run SQL Server 2005. So let's run it. I'm going to run two commands. I don't want to worry too much about what these commands are. I'll talk about them once I actually get this started. So I'm going to say Docker run. I'm going to point it to my SQL Server 2005 image that it basically just created. So now it's spawned the container. This is Habitat supervisor output that we're looking at. And right now it's in that init hook. So it's now taken up the endeavor of installing the .NET runtime, and it's going to actually install SQL Server. This is clearly going to take a couple minutes to run, which is great because that gives me some time to talk about those two commands that I just ran. So I'm going to run to the README, which again everybody here has access to. So you can look at this at your own leisure. But I just really want to zero in on these two commands that I just run because this kind of talks about something interesting in the Habitat lifecycle. So if you remember back, we've been talking about these templates and these double braces, and it's the ability for us to be able to inject data at runtime that the supervisor is aware of for its environment. And if I don't tell it anything special, it will just pull the values that I put in my default .toml file. file. And for SQL Server 2005, I wanted to, in my default.toml file, I had the network service account to run on, because that's a good, safe default for running the SQL Server service, unless you've got like your own service accounts that you want to run. Well, in a container, that is not a good default. This is a known issue with SQL Server. In a container, it's really best to run, like as in if you want SQL Server to run at all, it's really best to run SQL Server under the system account of that container, as a safe default. So I need to be able to override what's in my default.toml. So I tell it, hey, I want the service account to actually be equal to this. Also, in a container, we can't talk to the Windows Update servers. So we need to tell when we enable the .NET 3.5 feature, we need to give it a specific source as to where to find the source files for the .NET 3.5 runtime. I have pulled down those source files and have them locally in my environment in my C/SXS directory. In this README, which you can see, you'll find full instructions as to how to get those yourself, even if you don't have a commercial Windows disk available to you. You'll see how you can get them for free. So I put them in my C/SXS directory. So I need to be able to tell my DSC engine at runtime, hey, use this source and use this location. So I express this in JSON format, and I feed this to this environment variable called hab_SQL Server 2005. So when the Habitat Supervisor starts, it looks for all environment variables that begin with hab_. And then when I load up a service, so in my case, I'm loading up SQL Server 2005, it looks for all the suffixes that match up with my service name. So it's going to see this and it says, oh, okay, I'm going to use this configuration and override the default configuration with this configuration. That's one of a few ways, actually, that you can inject at runtime your own configuration. But that's what we're going to do here, because when we call Docker run, so the next thing we do is we call Docker run, because we have an image that represents our SQL Server 2005 application. And we're going to tell Docker run to use this environment variable that we defined up here to make sure and include that environment variable in the environment of the container that it spawns, so that way our supervisor will see it. And also, for the C/SXS directory to have any meaning, we need to be able to mount it to our container. So that way, C/SXS in the container will mount to C/SXS in the host, and I'll be able to successfully get those runtime files. So let's look and see where we are. Okay, well, it's still installing SQL Server 2005. It's probably right at the very end, and we can actually move forward. We don't have to wait for this to end. But basically, what I would expect to see, oh, here we go. So it just finished installing SQL Server. It's now entering its run hook. It's actually starting the SQL Server Windows service. And now SQL Server is running. It's finished up some post-run stuff. And now we're good to check this out. So the easiest way for us to check this out is to, first we have to find the IP address of the container. So I'm just going to do move this up so I can see. Docker PS, and I'm going to copy my container ID, and I'm basically going to do a Docker inspect and give us this format string that says, just show me the IP address of this container. So here's my IP address. So now the easiest way for me to validate all this is basically to go to SQL Server Management Studio, connect to my database engine. Here's the last time I used it, so I'm just going to replace this IP with my new IP. I'll put in the SA password. And bam. So now I have, in my local environment where I have no SQL Server installed, I'm connected to my container running SQL Server, and I see all the system databases. So that's great. We're good there. So now what we want to see is these two services running together. And I can now kill this particular container, which I just did. The problem that we have now is that now that I've killed this container, if I want to start up new applications using that image, I am always going to have to go through that 5-minute setup process to wait for this container to come up and install SQL Server. Clearly, that would not be fun. So what I do instead is I'm going to do a Docker commit. I've already done this. I'm not going to do this now, but I can commit this container. So I can commit the state of this container to a new image that basically has everything ready to go for me. I've got a clean instance of SQL Server installed. I've got the .NET 3.5 runtime. I'm ready to go. So with that, let's actually spin everything up together. So to do that, I'm going to use Docker Compose. So this is my Docker Compose YAML file, and this is just an easy way for me to do this. I've got two services here. I've got SQL Server 2005. I'm going to point it to the image that I've committed that I just talked about. So this has SQL Server installed on it. Then it's got my image for my web application. It's going to forward port 8099 locally, so that way I should just be able to hit it on my local IP. And then it's going to forward this. So this basically Docker Compose, everything inside this command, Docker Compose will append to Docker Run, which basically gets forwarded to the Habitat supervisor. So these two parameters are key. So the peer parameter is going to tell Habitat, you can find this other supervisor running out there, because this is going to start two containers with each having their own supervisor. But in order for anything to really happen, those supervisors have to see each other and talk to each other and share their information. So it's going to say, hey, the SQL Server 2005 is the host name of the other container. So peer up with that one. And then once you've done that, you should be able to bind to the database. So I give it this bind argument. I say, remember that database alias we talked about over here in our plan? So that was, my mouse is not moving. There we go. So that's this guy right here. So this database, well, you're going to find a service that basically complies and it's going to expose to you those arguments. That service is going to be called SQL Server 2005.default. That's what the supervisor knows the service to be. Because we're communicating with the other supervisor, we can see that. So let's actually do this now. I promise you this is we're in the last stretch here. Okay. So I'm saying Docker Compose up, so it's going to find that YAML file. It's going to launch these two containers. So first of all, it's launching the SQL Server container, so it's launched that. Now it's launching the our web application container. And once the web application container launches, we're going to start to see the Habitat supervisor output start spitting out to the screen. So here we have the supervisor output. So this is running through those init hooks. And this should actually run pretty quickly, because what Habitat will do, it'll say, oh, I see SQL Server's already installed. So I don't need to install it. The DSC is idempotent within itself. So it'll say, oh, the .NET 3.5 runtime is already installed. I don't need to install it. So really all it has to do is just some minimal information. So it should just be a few seconds, and this should all really be done. In fact, already, so the SQL Server is starting up the SQL Server service. It's waiting for it to start. Okay, so SQL Server is actually running. And the next step is so we're applying our DSC configuration on the web application, and then okay, so my web app is now up. So I can now go to my browser. So here's my local IP, and this is basically the home page. I'm going to refresh this, and I am going to, so here it is. This is my circa 2007 website that I can administer my database with. They're both running in containers, talking to one another. So that is pretty fantastic. I'm going to stop sharing now, because that's really all the demo I'm going to see. Now I just want to skip ahead so what did we just see here? So I now have a package that I can run on any modern Windows OS where a Habitat supervisor is running. So we saw that in a container. Chances are you're not running in a container. I feel pretty confident that the vast majority of people listening are not running their production inside of containers. That's okay. This can run on bare metal. This can run on VM. All the Habitat supervisor needs is compute. And so typically the Habitat supervisor would run as a Windows service, for example, in a VM environment. I didn't have to learn a new language, and I don't have to guess what any magic DSL is doing. This is all just PowerShell. If I'm comfortable with PowerShell, then I should have a clear view into what Habitat is doing. And lastly, I now have basically executable documentation for how to take my legacy application and have Habitat implant it in a variety of different environments, as long as that Habitat supervisor is running in that in that environment. And then here's a copy of the URLs that you're welcome to look at your leisure. And I know that we went a little bit long there, but we could definitely have some time to take some questions.
Yeah, thanks for that, Matt. And for some of them that were low-hanging fruit I felt I could speak to, I went ahead and responded in line. We'll go ahead and summarize a lot of this when we do recap. But I think probably the most directly pertinent here is someone asks, so in this example, we're using SQL Server 2005, for which support ended in April 2016. So the question is essentially, how does Habitat help us mitigate the risk of running software for which no security updates are being released?
Right. So, I mean, that's a great question, and there's all sorts of potential scenarios here. I mean, I guess to answer that directly, it doesn't. Which I know probably isn't the answer that you want, but clearly, so Habitat's not doing anything sneaky here. That's one thing I want to emphasize. So in your scenario, let's take SQL Server 2005. Obviously, I think most of us are aware of this. The best thing for you to do, or for anybody to do, is to not be running on SQL Server 2005, right? Like the best thing is to upgrade to a supported version of SQL Server, and clearly, like, we would all do that if we could, or if it was easy. Usually, the only reason why people are doing that is for whatever reason, the software that they're running will only work on that version of SQL Server 2005. So that is definitely a separate problem, and it's absolutely, like, in everybody's best interest to get on software that is supported. This is really a scenario like, if I'm stuck, if I I would love to be running on supported software, but I just can't. Here's something that I can do to mitigate that situation.
Yeah, and I think, like, another good point there as well is that we're able to sort of limit the surface area of our risk by containerizing, or at least packaging in this way, right? Because now we can run it on at least a modern OS, and so we're not taking the baggage of an EOL'd OS to run our EOL'd service on.
Yeah, that's a good point.
Yeah, let's see. We might have time for one last quick one. So someone asks whether it's possible to have a Habitat plan that runs a chef recipe or cookbook.
It absolutely is. So, in fact, we actually have customers that are doing this today. So basically, there is a Habitat plan for the chef client. So if I want to run the chef client as a Habitat service, I could do that. So basically, and there's that. It's actually, I don't know if there's any blog posts that cover this, because it's a super neat pattern. If there's not, I'm sure there will be, and I'm sure we could point you into somebody that could tell you more about this. But we have this way that basically we create a Habitat package using a policy file. And so basically what we package is the actual cookbooks that we want to run on the node. And then in that Habitat's run hook, it basically runs the chef client and runs those cookbooks. So we can build our Habitat package based off a snapshot provided by our policy file, and then have Habitat basically run that client run. And you can run it on intervals. So basically, it's one way to run the client, a chef client on Windows, without running it as a Windows service or a scheduled test, but as a Habitat service.
Yeah, and on a related note, when we do a blog post to recap this webinar, I'll include a link to a recent blog post we had from one of our engineers, John Snow, who ran through a presentation we did at ChefConf that showed off just this functionality, complete with the how-to for repro. And I think with that, we are just past the hour. So I want to thank everyone for joining us. And Jamie, do we have any sort of closing housekeeping to do?
I think maybe we lost Jamie.
We may have, but at the very least, I can happily answer one last question, which is simply the King of the North, ? And yes, he's a modest man, but he sure does lean into that name, and I love him for it.
Great. Well, thank you. Thank you, everyone, for listening. It was a pleasure to give you this information.
Yeah. Thanks for joining us. You should get some links to everything after the recording is posted. And as mentioned, we will usually do a recap blog post with a link to video within a week or two from today. So once again, thanks everyone for joining us today. And any Q&As we didn't get to, we'll go ahead and try to cover in that recap.